time has come for the event we've all been waiting for this summer, bringing together global talent from around the world. Let's go! No, we didn't mean that event. We meant the one with impact, financial inclusion. It's time for finals week. Coming up today, Aditi, Craig, Mansi, Raghav, Albin. Hello, everybody. Welcome to Finals Week 26. I can't believe we're already there. It seems like only the other day we were starting out the interns for this summer. It's great to be kicking off with Mifos X and looking at some of the exciting work our interns have been doing today. As we say, the clue is in the title. It's Finals Week, so we have 4 of these for you this week. With lots and lots of content, but I'm really delighted. We've got a really great set of projects, quite diverse, different things to kick us off. Without any further ado, let's get into some exciting content. So, Aditi, first of all, over to yourself. Do you want to talk about what you've been doing this summer for Mifos?
Yes. I hope my screen is visible.
Yep, we can see that. Thanks.
Hello, hi everyone. I'm Aditi Nikam. I am Google Summer of Code 2026 participant working with the Mifos initiative. I'm currently pursuing my master's in computer science at the University of Illinois, Urbana-Champaign. And my background is in computer engineering with a particular interest in backend and distributed systems. This summer, I worked on refactoring FinRect's command processing and command query responsibility segregation subsystems. Today, I'll walk you through the problem I started with, what I implemented, a short demo, and the changes, what looked like in practice, the approach that evolved during the project, and what I discovered along the way that enables the remaining migration. Moving the main objective of my project was to move FinRect's write operations from the legacy command processing pipeline to newer typed command dispatcher infrastructure. The motivation behind this was to bring stronger type safety into the right path and make responsibilities between the different layers much cleaner. The larger migration covers a much bigger part of FinRect, so I wasn't trying to migrate the entire system myself. Instead, my strategy was to take selected modules through the migration end to end, understand the problem and edge cases that come up during a real migration, and then turn those learning into a repeatable pattern that other contributors can use for the remaining module. So the project was really both implementation and pattern building. To understand why this migration was needed, let's look into the old pipeline, what it looked like. The fundamental problem with the legacy architecture was the loss of type information. As the API boundary, we started with a structured typed request, but as the request moves through the old command processing system, it gets converted into generic JSON and eventually into structures like maps. At that point, the system has lost the information the compiler could have used to help us. Developers then have to rely on string keys, manual casting, and manual JSON parsing to figure out what the request really contains. And that's where the problems show up at runtime. If one part of the system assumes a field has one type and another part interprets it differently, the compiler can't catch it because everything has already become generic data. So the deeper problem wasn't that the code was old, it was that the responsibility was mixed together and type information was being lost across multiple boundaries. The new architecture tries to solve exactly that. This is the main architecture transformation behind the project. On the left-hand side is the legacy flow. A request comes in, gets converted into raw JSON, gets routed using string-based identifiers, and then has to be manually passed again before the business logic can actually use it. On the right-hand side is the new typed flow. We start with a typed request DTO, validate it at the boundary, wrap it into a typed command, and send it through command dispatcher. The dispatcher finds the appropriate handler and the handler delegates it to the type write service. The important part is that each layer now has one job. The DTO is the API input, the command is the operation, the dispatcher routes, the handler bridges, and the write service does the actual business work. So instead of every layer trying to interpret generic JSON, the request stays typed throughout the flow. The goal is not simply to replace one class with another. The goal is to make the execution path much easier to understand, maintain, and validate. Keeping this structure in mind, I applied the migration to four modules: floating rate, standing instruction, history, and charges. Rates give me relatively a straightforward example of taking a module through CQRS migration. Standing his instructions was more interesting because it involved more complex validation as well as authorization for the run history function. And charges become another important migration because it also exposed a database portability issue that I'll come back to later. Across these modules, the work wasn't limited to introducing new commands. I also moved request models towards typed DTOs, introduced declarative Jakarta bean validation, updated authorization, cleaned up the read-write service segregation, and most importantly, removed the corresponding legacy write paths. So I wasn't leaving both implementations running in parallel. The migrated modules actually moved into the new architecture. So let me show one of the migration that actually looks like. I'll use the charge module as an example. At the API layer, we now receive typed charge create request. You can see that at the rate valid annotation here, which means validation happens at the request boundary. We then create a charge create command for the request and send it to the command dispatcher, which is responsible for finding the appropriate handler. The handler itself is intentionally very small. It receives the typed command and delegates to charge write service. That's a deliberate design decision. The handler is not supposed to become another place where the business logic accumulates. Its job is essentially to connect command processing infrastructure with the business layer. So if we follow one request through the system, the flow is charge create request, charge create command, command dispatcher, charge create handler, charge write service. And because every step in the chain is typed, the compiler can watch a whole class of mistakes that used to surface only at runtime. For the demo, moving on to the demo, um, I'll start with the legacy code. So I'll use the rate modules. This is the simplest one. So the whole path fits on the screen. The class name reads as floating rate because that's the feature inside this module. The serializer, which turns the request into JSON and the command sources, is what is wrapped to. The arranged steps builds a realistic request in one rate period, and the result I want is carrying resource ID 7. Then the two stubs, the serializer returns the JSON for this request and command services and wrapped and returns that result. The action is string create. The entity in the string floating rate, those aren't cosmetic label. Command handler provider joins them with a pipe. So floating rate pipe create is literally the key that resolves the handler at runtime. And command wrapper derives its permission and name at action underscore entity, which gives create underscore floating rate. Then the endpoint at floating rate. The variable plane shows that the request has declared type floating with a 4 populated field. And then to API JSON serializer request. The return type is string and the plane now holds the JSON text declared type string. There is no reference back to the floating rate. So this test exists because there is nothing the compiler checks at any of it. 3 string literals resolved reflective at runtime, get one wrong and it compiles cleanly, then fails in production. Now moving on to the same endpoint in the new architecture. So here, one request with the single rate period with an expected response resource ID 11. So the dispatcher is stubbed to return a supplier, not the response directly. Dispatch returns supplier's response, and that deferred in the call in the part of the contract. Then we verify that the dispatcher was called exactly once, and the command is as same as the request, not is equal to. At the same point, request has declared type floating rate request. Note the object ID in the plane. Uh, in the plane is the floating create command request type and the response type both in the signature so that the checked compile time. The parameter crossing into the command layer is the DTO. There is no string on the path. Now look at wasn't here. Every string that comes in the previous version is gone because the command's type is the routing key now. Java C does that job. What's left is only that a compiler genuinely cannot check. The hands-off happens exactly once. The payload passes by reference and the response passes straight back. But this migration didn't end up being the simple one-on-one translation of the old code. Some of the design changes was worked as I moved throughout the project. Validation is probably the clearest example of how my approach evolved. Initially, my plan was to migrate the existing problematic validators into the new architecture. In other words, I was essentially going to take the existing validation logic and reproduce it using the new typed request and command structure. But during implementation and review, we realized that this would actually carry some of the old design into the new architecture. Once we already had type DTOs, a lot of validations could be expressed directly as declarative constraints. So we moved towards Jakarta bean validation instead. This means that instead of manually writing code to check every field, constraints could live directly to the request module and be evaluated at the API point. For me, this was the important lesson from the project. When you're migrating an architecture, you shouldn't blindly reproduce the old implementation inside the new architecture. And that mindset led to an unexpected benefit. While migrating the modules, I started finding issues that weren't really part of the original migration objective. The first example was in standing instructions. While working through the validation rules, I found that the existing validation metrics didn't completely cover the intended conditions. In particular, there was missing inverse condition around the amount field. So I added the missing validation rule along with tests to make sure that behavior was explicitly covered. The second example was in charts. While migrating the database related logic, I found native SQL condition that behaved properly in MySQL was but wasn't portable to PostgreSQL. Instead of carrying that query into the new implementation, I replaced it with JPQL queries. So these weren't bugs that the migration introduced. These were existing assumption or gaps that became visible because I had to understand the old implementation closely enough to migrate it. And this became one of the biggest takeaways from the project. Larger migration can also act as an audit for the existing system. Another important consideration was making these internal changes without unnecessarily breaking existing clients. Standing instructions gave a good example for this. The existing API exposed deletion using a put endpoint with a command parameter. From a REST designs perspective, you might look and say, let's change this to a delete endpoint. But that would turn an internal architecture migration into a public API chain. Existing client could potentially depend on the contract. So instead of the internal implementations change, we introduced a typed delete standing instruction command and routed it through the new CQRS infrastructure. But externally, we preserved the API behavior. This means that the client didn't need to refactor. They changed because the internal command processing architecture changed. So, after going through this migrations, what did the project actually leave behind? The project resulted in 4 units of the migration work. 3 PRs have been merged, and one is currently open. The implementation itself is complete across the planned migration work. I migrated the floating rate, standing instruction history, and charges to the typed CQRS path. The important outcome is the legacy write path are removed rather than leaving two implementations running in parallel. Through this work, I've documented the entire migration, covering the process from request DTOs and command creation through handlers and write service to validation, authorization, cleanup, and testing. The larger migration still has around 40 modules remaining. So the goal of this work was not only these modules be the end of the story. The goal was to make the next modules easier for the other contributors to migrate. And this leads to what's next. So personally, I want to contribute to Finerect and the Mifos community beyond the GSOC project. In particular, I'd like to stay involved with the remaining migration work and help drive or reviews the additional migration PRs where I can. From the technical perspective, this project also reinforced my interest in backend architecture and distributed systems. Working on a large production code base like Finerect gave me much better understanding of the challenges involved in changing architecture without breaking the existing behavior. So that's something I want to continue exploring in my future work. Also, for the community, the immediate next step would be migrating module by module migration across the remaining modules. The migration documentation should be easier to parallelize rather than requiring each contributor to rediscover this process. There are also some border architectural questions that remain. One is continuing to standardize the sync CQRS architecture. There is also some decisions around remaining REST work and delete operation convention. And there is future work around the performance of potency check in the command pipeline. And I've put all the implementation and documentation in the following resources. So for anyone who wants to go deeper into the project, I've included the main resources here. First is my final GSOC report, which has the documentation for the architecture, the migration process, design decisions, and all the lessons I've learned. I've also linked the Apache Finerect repository, the project epic, the pull requests associated with this migration work. I've also included the GitHub, so you can see the implementation and the contributors can be found here. So to summarize this entire project in 3 words: refactor, discover, and enable. Refactor, I moved untyped command processing toward typed CQRS. Discover, the migration exposed validation and database portability issues that we were able to fix. Enable, 3 PRs are now merged, one is open, and the work has resulted in reusable migration documentation for the remaining modules. So for me, the biggest takeaway wasn't simply these 4 modules being migrated, it was learning how to make a significant architectural change in real production system while preserving the existing behavior. Uh, res- Responding to review and new discoveries and leaving the code base in a state where the next contributor can continue to work. Before I close, I also want to thank a few people because none of this happened on my own. Firstly, my mentors, Avinash and Francisco, who supported me in every way possible, helping me finding my ways around the code base early on, to thinking through the decisions, design decisions with me when the plan changed. And I would also like to thank Alex for reviewing and approving my pull requests. Those reviews genuinely shaped the work. The move to declarative validations came directly out of review discussion. And lastly, I would like to thank Edward and David, who are always available to help and who do so much to support this community. And also a shout out for the Friday community call. On paper, it's just the update call, but for me, it was a place where I could see what was actually happening across the community and how my project was heading towards. So it was a big part why I felt like a contributor and not someone working on the isolated task. And these are the main reason I would like to continue working with the Mifos initiatives beyond this program. And if anyone wants to reach out for more information, I've the QR code on the screen, LinkedIn, and Gmail. Feel free to reach out. Thank you so much. Over to David.
Thank you, Aditi. That's great. And it's really good demonstration, a great way to kick off finals week, seeing all that work that you're putting into the Mifos X core and how that's going to become so much better architecturally, so much more robust. And I think the bit that really shone through was how you're doing this approach to so that others can pick it up as well and continue that work and continue building its strength, moving forward. So I think it's a really great way to be thinking about it as you go through these projects. And yes, definitely you can stay part of the Mifos community. We're looking forward to that, and all the contributions that you're making upstream towards Finact as well, to make that
Yeah.
stronger. So no, thank you very much. It's a really good start to it, and probably a really good place to remind everyone as well. We have the Q&A facility, so if you want to raise some questions, we will try and make sure there's some time at the end that we can answer those questions as well. But thank you very much, Aditi, and thank you for going first. I know it's a tough gig to do, but you did very well. Thank you very much.
Thank you so
um,
much, Dave.
Now we're going to move on a little bit, staying focused on Mifos X today, and some of the great stuff that's going to come up in the next Mifos X release. Moving away from the Mifos X core, we're going to look a bit more about the new exciting stuff about the user interface. So I'm delighted we have Craig with us today. Craig, over to yourself to tell us what you've been working on this summer.
Yeah, so hi everyone, my name is Craig Rosario, and I've been working on the Mifos X web app React version part 2. So a little about what I'm going to be explaining in this presentation is basically who am I, what is the project overview, what kind of work progress has been done, the future work, and as well as a short demo. So build one, reuse everywhere. This was their quote since last year. Um, Basically, the Mifos X React web app was built basically to make it more modular, make it more developer friendly so that it can be easier to contribute to. And React was a good alternative to the Angular version. So this code still stands, build one, reuse everywhere. Basically, it tells us about the modularity and the consistency of the code base. So who am I? Basically, I'm Craig, and I have been working on this project since last year. This is my second Google Summer of Code with Mifos. In the first GSOC in 2025, I started with building the core foundations of the React web app, where I migrated uh, lots of modules, 80 plus modules to be exact, and that laid the foundations of the new React web app. Now, this year, what I did was basically, since the React web app is a huge project and there are multiple workflows which were basically missing or which have to be implemented this year, which basically my project this year covered. So the project overview is you have to understand from by basically looking at the project why the project was built. So first we have the Angular web app, which is the interface for the Mifos X web app. It was built using Angular, and last year the community came through and they wanted to switch to a newer version, which could be more modular, more developer friendly, and just better to contribute to. And I feel Mifos React web app was made that last year. And basically, I was the first one to contribute to it. I laid the foundations of it. This year, it basically builds on that foundation to reach more feature parity with the existing web app. So the goals of the project were basically implementing remaining modules. There were some static pages. There were some pages which had some API issues, maybe some CRUD issues. Then the main part of the project was basically build a core multi-step form feature. So last year, basically the multi-step forms were not really functional. The multi-step forms are functional this year, and basically it has been turned into a reusable component, as I said before, using the code. Now, basically, in the future, if anyone wants to contribute to it, it's basically just a component, and you can go ahead and build your multi-step forms pretty much easily. All the state management and all the checks are already done using the component. So also tighten the API fixtures using the OpenAPI TypeScript client. Also, main part of this is to maintain the code quality, error handling, and basically make it more feature parity and more reliable, so that it could be a great alternative moving forward. So work done. So as I said, the multi-step form, which was used for the savings product, loan product, creation of clients, and group saving application, etc. There are multiple multi-step forms used in the Mifos React web app. Basically, all of them are a single component now. You can just import them and just add your pages according to the type of product you want to build. Other than that, I have been working on uh, four basic four main pages. First is the admin module pages, which covers the templates, products, your organization and systems. I'm not going to note down because there are a lot of pages which were built and touched up this year, but these are the core interfaces which were built. Then you have the institution module where we created the client multi-step forms, saving account, share account multi-step forms, as well as additions to the groups and centers, as well as we had the accounting modules where I fixed multiple pages in the accounting rules, and the documentation finally. So the documentation, obviously, we had the documentation last year, which was basically how do you set up the React web app, as well as it has been Dockerized now. So you can run it through Docker, or you can run it directly on your local machine using Finerect. What I actually worked on the documentation is the issues.md file. Last year, issues.md was basically created um, to basically note down the OpenAPI issues. So OpenAPI issues is basically your backend, and the React web app depends on it. So there are multiple endpoint gaps. There might be some stuff which is wrong or some stuff which is not existent in the TypeScript generated client. So all of these issues are documented in the issues.md file. So basically for future contributors, it could be easier because, instead of actually searching for the errors, you can just look at this file and you can actually tactfully like locate the errors and fix them there and there. So future work, these are the, I guess, 3 main points which I noticed is better UI and UX integrations. What could be done in the future is basically including some loaders, including pop-up messages. Basically, this is the kind of polish that you put on your project, but the most important thing that has to be added is the Open API enhancement. And this is the sort of issue that's on the backend side of things. Basically, you have a YAML file which is generated from the OpenAPI client, and basically it has a lot of things which is missing or incomplete or straight up wrong. This was one of the issues which was noted down last year as well, and there are some issues which have been noted down this year as well. So I feel the next step into the React web app would be actually focusing not only on the front end and the React side of things, but also fixing the back end at the same time so that, there are some pages which are blocked due to these back end issues. And if they are fixed, you can go ahead and build your front end pages for it. And also, if we do it, it can completely reach feature parity with the Angular web app. The last point, which is basically the contributions. This is not really a feature or future work, but it has almost been a year since the React web app was built, and it has gained over 25 new contributors and 50 plus forks. And this is the kind of the magic of open source is basically you see a project which was basically non-existent last year and how it's come through with so many contributors and so many changes over a year. It has been great to see, and I hope the project does continue in the future and reaches, the main Mifos X React web app. So a short demo, basically what I did this summer. Yeah, so basically I'll just show you what is the multi-step forms because they were the main issue. So this is basically loan products. You go to products and you create a loan product. So this is the basic structure of the multi-step form. So do note that this is a modular thing. So if you want to create, suppose, another multi-step form, you just import it and you create those pages. So this is the loan product of how it basically is. So now if you look at something like fund and missing in Open API, this is the exact type of issues I'm talking about. This kind of the basic backend endpoint does not have the fund does not have fund in basically its interface, and hence it would you cannot implement it into the front end. So these are the small kind of issues which have to be fixed. I have noted it down over here as well, so it's readily apparent for future contributors. So this basically has a set of pages, same as the Angular web app. I have the Angular web app over here. It's basically the same thing. So the load product is quite an intensive multi-step form. So I'll just show you a shorter version of it, which is the client form, which only has like one example. So I'll just create an external ID. This is just for test. Do not take it literally. So just read React test. I enter my board date. As we can see over here, gender is missing in Open API stuff. So see, there are most of the things are available like mobile number and email address, but there are some things which are not, which have to be fixed in the future as well. This is just a dummy thing, so do not take it. And let's just not activate it for this one. And since we didn't activate it, it should be in our pending clients. And this is basically how the multi-step form works. And this is basically your clients, one of the clients which I've created. And also just to show what kind of accounting rules, what kind of pages I was talking about other than the multi-step forms. There were some pages which were not exactly built, or they were not working, or they were static. One of them which was accounting rules. Let's just give it a React test one. Accounting rules. And that it is. That is our accounting rule. Basically, it is to show that some pages were not available last time and they are fixed this time. So I do not want to go into the depth, but basically these are the two main types of errors which we were facing last time. First was the multi-step forms, which are not implemented at all, and there were some pages which were static, which are rebuilt now. So that is basically the whole project. What I want to say is this project I've been working on it since last year, and to see it has been grown from a small repository to something big. Like there are multiple contributors, and it has grown so much, and I hope it grows much further and becomes the primary interface for the React web app, primary interface for the Mifos X web app. I want to say a thank you to all the mentors, especially Aru. He had been merging my PRs every single day, and also he helped a lot in deciding the modularity of the multi-step forms. We had many issues where if we had to make it into a single file, but that basically had some state management issues. So you had to go to a modular way where you have to check every rule. He has helped me a lot in this project as well as all the other mentors. And I would like to thank Ed and David to be a great addition to this, as well as the Mifos community. And obviously, the way they have structured the Google Summer of Code has been a great experience. If you want to contact me, here's all my details, my portfolio, GitHub, LinkedIn, the React web app, as well as I'm available on Slack. I'm just Craig over there. As well as I'd like to see the future contributions, and I'll be contributing to the React web app as well. I'll be available. So if you have any issues with the React web app, feel free to contact me on any of these. So yeah, that was it for my final presentation. Thank you very much, everyone.
Thank you, Craig. And it's great to see what's happening with the React web app, and spot on exactly. This will be the future of Mifos X, and hopefully not too far off being the future of Mifos X moving forwards. It really is the modern approach to doing these things that we want to exemplify. It enables all of our modularity that we want, and it's a platform that developers can continue to develop on. So it's really important for us to be able to get to that point of parity with the Anglo app at the moment, and then move away to this much better platform for developing and meeting the needs that, clearly myself, Ed, and Alex here every day when we're talking to customers and end users, that they need that features that only the React basis can give us. So thank you for the work. And as you said, it's great to see that uplift in general in the number of people interacting with the repository and contributing to it. I think that validates we're taking the right approach here. Thank you, Craig. It is absolutely great. Next, we're going to move on to Mansi, and this is a great segue. Someone might almost think I'd actually planned this agenda, but modularity in the front end requires modularity and event-driven architectures in the back end. So that is what Mansi's going to talk to us about.
So hi everyone, I'm Mansi. My project this summer was about cross-feature boundary violations in Apache FinRack. So in simple terms, I measured how tightly FinRack's features are connected to each other, decoupled the features that the measurement highlighted, and added build time checks so those boundaries stay clean. So next slide. Just a quick introduction about me. Before this, I worked in banking technology at Standard Chartered Bank on production financial systems. And now currently I'm now doing my master's at TU Dublin. I came to FinRack because it is the same kind of system I already understand, but it also serves people who otherwise may not have access to banking. So what I wanted from this summer was to make a real architectural change in large, mature code base and to discuss and justify that change openly with the community. Next slide. Okay, so this slide shows the whole project in one view. So FinRack is organized into modules that are meant to represent separate features. But in the actual code, those boundaries are often crossed. So when I measured the platform, only 2 out of 20 features had like no cross feature dependencies. In many cases, one feature imports another feature's concrete classes, even when it only needs something simple like an identifier. So 9 of these dependencies are mutual, and together they form one like central cycle around like loan feature. So the biggest problem was that none of this was being measured. So these dependencies could keep growing without anyone noticing. So the approach on the right is the solution that works for like most cases. First, like invert the dependency through the contract placed in FinRack core, and then replace the object association with identifier references. And after that, add a boundary test so the dependency cannot come back, and rerun the measurement from the build so we can keep seeing whether the architecture is improving. And not every violation can be solved in exactly the same way. And I'll come back to this later. So the goal at the bottom is the realistic goal for one summer, like make the platform able to prove its own modularity on any checkout, measure the baseline, decide like what is worth decoupling, applying the right change, and enforce it. Next slide. Okay, so before I could measure anything, I first had to define the terms clearly, because simply using these modules are tangled does not tell us like what to fix. So a feature is a business capability that owns like its own data and rules, and a boundary means that code inside the feature can use anything that feature owns. So like while code outside the feature can only use what the feature deliberately exposes. So a violation I will call like CFV from now on is like a compile time reference, like from a class in one feature to an implementation type in another feature. So the key distinction at the bottom, a loan generally has charges. So that relationship is part of the business domain. So architecture cannot remove it. But if accounting directly knows the charge class when it only needs like a ID and couple of fields, that is accidental complexity, because that accidental complexity is the part we can remove. Next slide. Okay, so this is the baseline, and every number on this slide comes directly from the build. So there are 115 cross-feature violation across almost like 14,000 class level edges. So I measured like 20 features and only 2 were clean and 12 were rated critical. So the important part on the left is all of this comes from one Gradle task. So anyone can run it on any checkout, whether the code is merged or not, and get the same results. So that reproducibility is important, like for everything else in this presentation. On the right is the result that shaped the plan, like loan depends on 11 features and 11 features depend on loan. So 9 of those relationships are mutual. That is not a simple like a layering problem that you fix by moving a class to another package. It is a cycle. So to break a cycle, you need to like invert the call, which is exactly what a contract and later an event is for. So the measurement led to the design. Like I did not start with the design and then look for the numbers to support it. Next slide. Okay, so here is like more realistic story of how I got those numbers, because it took like 4 attempts. So I started like inside the IDE, like with a metrics plugin. It showed me like how much coupling there was, but not the direction. I could see that loan was like heavily connected, but I could not tell like which way those dependencies are going. Also, nobody else could easily reproduce the same result. So like my mentor Alex suggested like moving the measurement to the build. So that became step 2, and it was like most important change in the project. So a Gradle task over like compile bytecode gives directed dependency graphs from like a clean checkout, and anyone can run it also. So once the data came from the build, I could like generate the charts from the data instead of drawing them manually. Then the documentation could also be generated from the like the same output. like including the per package sections and the case studies. So the pipeline at the bottom shows the full flow from like start to finish. One command runs the whole thing. Next slide. Okay, so there were three important course corrections along the way, and I think they are like actually more useful than the original plan. The first one nearly like broke the whole project. Like I was running the metric tasks separately for each module. So the problem is that doing that silently removes every cross module edge. So which was exactly the information I needed. There was no warning or error. The report looked complete, but it was measuring almost nothing like useful. So I fixed that by switching to one aggregate scan across the whole platform. Second, like I was assigning classes to features using package names that does not work well for deeply like nested code. So for example, fixed and recurring deposit live inside savings. So the heuristic made them look independent, even though they are actually among the most exposed parts of the platform. And third, like a single toolchain gives you no real way to check the result. So I measured the same platform in two ways, through the ID and through the build. So they agreed on 11 out of 17 features. So those six disagreements were not just noise; they were like an important finding also. Next slide. Okay, so this table comes directly like from the build. The C means what a feature depends on, and CA means like what depends on that feature. And I is like here instability, and CFP is like the number of cross-feature violations. So loan and savings are the worst, and with 11 each, accounting, client, and account transfers are at like 8. So in total, 12 of the 20 features are rated critical. But the most interesting row is near the bottom, user administration. So it is like it reaches out to only two things, while 15 features depend on it. So if I only looked at the total amount of coupling, it would look like a problem, but it is not. Like it is a shared foundation. And this is exactly what the healthy layering should look like. So we leave it alone. So that is the main lesson on the right, and it changed the order in which I planned the remediation. Like what matters is the outward reach. So if a feature has like high incoming dependencies but low outgoing dependencies, the architecture is working as intended. So that is why CFP count alone was like a poor way to decide what to fix first. So if I had simply sorted by violation count, like I could have spent the entire summer like refactoring something that like did not actually need to be changed. Next slide. So one more way of looking at the data quickly is like distance from the main sequence tells us like how far a feature is from healthy balance between being abstract and being heavily depend on. So organization and user administration score high here, but as I just explained, like that is partly intentional because they are foundation modules. And charge is the important one. It is like only have like 5% abstract, while 140 classes depend on it. That puts it like deep in the zone. And unlike the foundation modules, there is no architectural reason for charge to be there. That makes it like the clearest remediation candidate on the slide. And it is the feature I'll show in the demo also. Next slide. Okay, so like this is like before picture and it is generated from the build rather than drawn. So the key thing is to notice the dependency depth. The longest chain is like 4 features deep. A change in organization can like affect fixed deposit, and passing through savings and accounting on the way. That is how small change can turn into like platform wide regression. And loan sits in the middle at the depth 3. So it both depends on other feature and has other features depending on it. And the shallow feature at the bottom are the safer ground. That is where the contracts can move to. And that brings me to like what the actual fix looks like. Next slide. Okay, so most violation can be fixed with the same 5 steps. So I wrote the process down clearly. So first, like find the smallest amount of information the dependent really needs. Usually that is just an identifier and few fields, not behavior. Then define a contract that is owned by depending feature and place it in like FinRack core. And the feature that owns the data implements the contract, which reverses like a compile time dependency, and then replace the JPA object association with a like plain long identifier, and finally add a boundary test. So this is not a universal solution. It works when the dependent needs data. If it needs behavior, a read contract is not enough. So the dependency should be inverted through an event. If the relationship is like enforced in database schema, the change has to wait until the data model moves. And if the dependency is actually a platform concern, it should be reclassified instead of decoupled. So that is why charge is estimated to move from 6 violation to 1 rather than all way to 0. So like the table below is like a remediation plan, costed like case by case. And if I want to be like clear, so this table is design, not delivery. Like teller is estimated to go from 4 violation to 0 in 4 to 6 days. Like charge goes from 6 to 1. Similarly, like breaking the 5 cycles in 10 to 15 days. So these cases are like analyzed and costed, like they describe the next part of the work. Next slide. Is it running? Okay, so for this demo, I'm going to show like one concrete example of the modularization work, decoupling the charge feature from tax feature. So I've prepared before and after version so we can like clearly see both code level change and how the architectural boundary test validates it. So here I'm first comparing the branches. There's no unrelated root build. So the diff gives an overview of the actual implementation. And the change touches 10 files across the charge, tax, loan, and provider modules. So the main objective is not simply moving code, it is removing the direct feature-to-feature dependency. And also by preserving the existing functionality. And this is the important dependency change. Like previously, the FinRack charge directly declared a dependency on FinRack tax. As part of the refactoring, that direct dependency has been removed. At the domain level, charge like previously held the direct tax group entity reference from the tax feature. It now stores only the tax group ID. So when tax calculation is required, the ID is passed across the service boundary and the tax module itself resolves the tax group. So now after switching the before test branch, now this branch contains the like architectural boundary test, but still has the old implementation. So the test scans dependencies originating from the charge active artifact and verifies that charge does not directly reference another feature module. So the intended rule is that cross-feature communication should happen through the approved boundaries and rather than when importing another feature's internal class. So as expected, the test fails here. And then now I'm switching after this to another branch which contains the completed refactoring. So the direct tax group reference has been replaced by ID boundary, and the direct charge to tax gradle dependency has been removed. So now both, and in this case, like after the result, you can see like both tests will pass. So this demonstrates that like the complete cycle, we first detect the existing cross-feature dependency, refactor the implementation to remove that dependency, and then use an automated architecture test to ensure that boundary remains clean. So this is the pattern I'm applying across FinRack to make the module boundaries explicit and safer to maintain like over time. And next slide. Okay, so there are like 4 pull requests. So the design proposal FSIP 12 is merged, and like this defines the target and architecture and the criteria. So the Spring modular boundary enforcement that you just saw is also merged. Like two decoupling pull requests are still in review. So on the right are 6 more features that I decoupled on branches, calendar, charge, account transfer, fixed deposit, organization, and share accounts. All 6 use the same 5-step approach, and some of them use something different also. So that makes like 8 feature decoupled in total. The 6 on the right have not been raised as pull requests yet, and like I will explain in like the next slide. Can you move? Yeah, so if okay, so the read side decoupling is safe to merge now. So when I replace like an object reference with an identifier, the write behavior does not change. So that is the work shown on the left, and that is the work currently in review. So the middle box is the gate. So it is like the new command processing needs idempotency before more features can move onto it. So this matters especially in a core banking system. So once a command becomes an event, it may be retried. So if I retry command is not idempotent, it can create the same posting twice. So in other words, so the right side migration has to wait. The idempotency work is in progress, and the other 6 branches are staged behind that gate. So the project is like the migration order changed deliberately so that we do not introduce unsafe write behavior into the system. Okay, next slide. So the documentation is a deliverable by itself. So it's not just the summary of the code I wrote. So it contains around 1400 lines of ASCII doc plus 920 per package reference sections. So those sections are generated from the metric run instead of being written manually. So the documentation defines the terms, separates like essential complexity from like accidental complexity. It also explains like how to reproduce and challenge the measurement, give 6 criteria like for deciding whether a violation is worth fixing now, or also includes 3 case studies at different severity levels, and finishes with how to prevent the dependencies from coming back. So the main goal is is the next contributor inherits the method, not only the conclusion that is being given. Next slide. So what I like, the 3 things I understand now that I did not understand earlier was like, first, direction matters more than magnitude. Like I almost optimized for the wrong thing. So the difference between a real problem and like a healthy foundation is not simply how many dependencies are there. It is like which way those dependencies point. Second, like there's something I'll carry into like future work as well. So like if nobody else can produce a metric, then it is not basically an opinion with numbers attached. So the IDE result look authoritative, but nobody else could verify them. So moving the measurement into the build is what made every later architectural argument reviewable by someone other than me as well. And third, architecture is like a conversation, not a commit. So my 2 biggest course correction came from my mentor, not from like my own debugging. So the proposal went through community discussion before like the code was changed. Next slide. So for me, the next steps are to take the pull request and the stage commits for further than the review, and then rebase and raise the other 6 branches once the idempotency work lands. And after that, start introducing the first real events for like loan saving cycle. So after the internship, also I would be continuing as a contributor for this particular work. And for the community, the chapter ends with like ranked and costed sequence. So the next contributor does not have to choose a starting point blindly. Like first publish the ranked candidate list using the like 6 criteria across the full measured set, and then land the low severity case first, like teller, because it proves the pattern end to end without a boundary test included. And after that, extend the Spring modulate coverage feature by feature as feature is cleaned up. So like we can remeasure and publish the trend so everyone can see whether the architecture is moving in the right direction. Next slide. Okay, so everything is linked on this slide. The final report, the chapter itself, and the documentation branch, and the 4 pull requests, and the 6 decoupling branches as well. I would like to thank you to my mentor Alex. Like 2 of his like early interventions shaped the project more than anything I did on my own. And like I would also like to thank Apache Finrack community for taking like out an outsider's architectural opinion like seriously and reviewing them. And I would like to thank Edward and David also for like making this internship so meaningful and good learning opportunity.
Thank you very much, Mansi. That's great work. And you know, I really love the honesty you had as you went through that, you know, in terms of what you tried, where you'd had to sort of change things along the path. And I think that really shows, you know, that, you know, as part of an internship, it's actually part of a whole engineering journey within a project as well. It's not isolated. This is something that's going to go and be part of the Mifos X core in the next release, you know, and to do that, you have to do it in the right way, and sometimes you have to change your approach. Sometimes you actually have to step back and hold things until new things comes along. So, thank you for that honesty. It's really great work to see.
Okay, thank you.
Next, we're going to move on to Raghav. Raghav has been working on another important bit of modular modernization of the Mifos X product, particularly looking at the reporting engine.
So, hello everyone. My name is Raghav Agrawal, and for the last 3 months, I've been rebuilding the reporting engine underneath FinRact. And look at the three numbers on the right of the slide. 132 legacy reports become 66, and 5 output formats now come from a single engine. And zero time downtime is now needed to change a report. So those three numbers are the whole story. The next few minutes are about how we got there and what I got wrong along the way. So next slide. A quick word about me. I'm a final year computer science student at VIT Vellore, and backend and platform engineering is where I spend my time. But the most important part is on the right. I did not arrive at this project as a stranger. Before MSOC began, I had already merged 4 changes into the exact plugin, which includes a parameter validation bug that was blocking reports, a migration that had to be safe on both databases, and some localization cleanup. So when I wrote my proposal, I was not guessing about this code base. I had already been burned by it. So next slide. So why does this matter? Reporting is not a small feature at the edge of a banking system. It is where the system meets the outside world, and the loan officer, for example, a loan officer opens our areas list every morning. A branch manager closes the day against a portfolio summary. A regulator receives balance sheet that has to be reconciled exactly. So for over a decade, all of that ran on Pentao engine. And Pentao had 4 problems. First is of small bugs, which includes small bugs and structural bugs. So it includes license that does not sit cleanly inside an Apache project, and its dependencies live outside Maven Central. So builds break for no reasons that nobody can control. Every report was written twice, once per database, and nothing was verified automatically. So correctness was a human being with a postman. So on to the next slide. So the project had 2 halves. First, taking the existing BIRT plugin and making it production grade. A prototype was like there, but it was not safe under concurrency and not safe under load and not adoptable by a real institution. The second phase was automating the migration of 132 Pentao reports. Rebuilding each one by hand was never a plan, and one rule governed both. Remember this line because it decides 2 of my decisions later. So a report that renders beautifully and returns a wrong number is worse than a report that crashes. A crash is loud and someone can fix it, but a wrong number is silent and it reaches a regulator. Next slide. So when I audited the code, I did not find a bug list. I found 5 structural constraints that are shared mutable states across tenants, memory that was growing up with the report size, every report was maintained twice, and the template logged inside build artifact, and no automated tests at all. But look at the box on the bottom right. This was the most important decision of the project. I could not migrate 132 reports onto an engine that was not safe to run them. So I decided on the strategy that the engine first and migration second. So that one decision produced 4 phases of the project you are about to see. The next slide. So this is the entire project on this one slide. And on the left, the old world template logged inside the jar and the 2 template sets for 2 databases, an unpooled connection with credentials written into template file, and the whole report sitting in memory. On the right, there's a new world template resolved from databases, 1 template set with dialect handled at runtime, a pool connection managed by Spring, and a streaming render which allows memory stays flat, however the big report is. So every row on the right is a phase of work. Next slide. So the project contains of 4 phases that I executed that are isolation, performance, compiler, and delivery. So one property managed throughout every phase was independently mergeable. If the project had stepped like after phase 2, or Mifos would still have inherited a thread-safe streaming, dialect agnostic engine, and nothing depends on me finishing. Next slide. So the phase 1, this phase everyone stands on. Like the plugin cached compiled templates for speed, but on every request, it modified that cached object to at the caller tenant database, and BIRT does not copy the design when it runs. So two tenants are running the same report at the same time, but touching the same object. That is not a performance issue. In a banking system, that is a data isolation issue. So the fix is stage 2 on this rail. Every request now it gets its own copy, and the cache template stays read only. Here is the part I care about. Safety now comes from the design itself, not from how the cache is configured. So whoever optimizes the cache next year, for example, inherits safely, and they do not have to rediscover it. And next slide. So now the first thing I got wrong, my proposal promised a caffeine template cache. It was a headline deliverable and it was ready to build in for week 4. But then I read the code properly. BIRT caching already hands off to the Finrex's own cache manager, and whether caching is switched on at all is a deployment decision, not a plugin decision. So if I had built my own, I would have given the plugin a second and completing cache that no operator could see or control. So I deleted the deliverable and wrote the finding down inside instead, and I implemented a cache evict strategy, which led into the completion of caching template all over the plugin, and a proposal. So I included that in the proposal. On to the next slide. So phase 2 was making the engine a proper citizen of Finrex. Looking at the before code, the old plugin decrypted the tenant base database password and wrote the connection details straight into the report template, and then BIRT opened its own connection. That bypasses the connection pool completely, makes read replica routing impossible, and send credentials through a template file. Now it works the other way around. We take Spring own routed connection and hand it to the engine. One was story from the bottom down. When I added declarative transaction, Spring wrapped up my service in a proxy, and that proxy removed the annotation Finrex uses to find the reporting plugins. So now the plugin silently disappeared at startup. On to the next slide. So this chart is a clear picture in the deck. The red line is the old behavior and the whole report was built in memory before a single byte reached the user. A 50 megabyte file and export needed 50 megabytes of heap. That is crashing. That is causing a crash waiting for a busy Monday. So the green line is now rendering happens in 2 steps. Run the query and write result to the temporary file. Then stream the output straight to the response. So this causes memory stay flat, and whatever the report size. And rendering now sits behind one renderer design. 5 formats today, and 6 would like a 6th format can be easily added without changing the core logic. On to the next slide. So this is the change that permanently ended the duplication problem. Before there were 2 folders of report, the same report. The only difference was the small pieces of SQL syntax. One database says if null and other says collapse. So now there is a one folder. When a template loads, the engine detects the database is behind the request and rewrites the query before it runs. That halves the maintenance work and removes the whole class of silent bugs where two supposedly identical reports quietly drift apart. Now there was a quiet second win because the credential was no longer travel through the report parameters. I deleted the password description code from the layer entirely. Next slide. So this was the main phase of my project. I stopped migrating reports and instead I wrote a compiler that migrated reports. I've gone through the 3 stages. That is, first ingest, open the archive in memory and parse it. Second is normalize, turn into one clean engine neutral model. And third is to generate and build valid BIRT XML and write it out. The middle stage is the decision that matters. Everything downstream reads the that clean model, so the generator never inherits penthouse strangeness. Two details underneath parameter translation is shipped at 100% test coverage, and because of this, wrong parameter order means wrong data. And if one archive is broken, the bash does not die. It writes a marked placeholder and keeps on going on. So on to the next slide. So here is the headline number. I want to be precise, and because it's always invites a question. And 132 archives went in and 66 templates came out. The full catalog compiled in about 33 seconds. So why 66, not 132? Because the old catalog held every report twice, once per database. Now that engine handles dialect at runtime and each pair collapses into one file. The halving is duplication problem being solved and counted in files. Next slide. The second thing I got wrong is the lesson that I value the most. Some reports used old MySQL variable tricks to calculate running balances and order dependent logics written at like a decade ago. So my automated translation handled them. The SQL compiled, it ran, and it produced no errors at all. And it returned wrong financial numbers. Come back to the rule from the start. So the crash is loud and get fixed, but a wrong balance is silent and reaches the regulator. So I stopped and I quarantined those reports and rewrote them by hand. Those reports were around 12 out of 133, and they were fixed by a completely correct method by manual inspection. That is why the whole process is human in loop. And the compiled real deliverable was knowing which report it should refuse to touch. Next slide. So let me open about the method. Much of the project was archaeology. Thousands of lines of undocumented XML was with no author left to ask. Pentao and BIRT describe page layout in completely different language. So for each report, I pulled out the layout definition and used AI to draft the BIRT equivalent. Now, but for the fourth step, because that is the whole point, nothing was accepted just because it looked right. Every draft went through a assembler and renderer real PDF against a seeded database and was compared with the original. And if it failed, it would go back to step two. And every rule I learned by hand and become a permanent rule inside a translator. I documented all this automated translation using AI to help the contributors in future. So the pipeline got smarter and instead of more dependent on each contributor. Next slide. Huh. So phase four, the deliverable I'm most proudest of because it changes what institutions are allowed to do. I could have committed the 66 templates in the plugin source, but that keeps the original same, a rebuild maintenance window, and every time someone changes a logo or translates a label. So the template now lives outside the code. The engine look in the database configuration first, and then application settings, and then a default location. So I combined all that with a checksum work from phase one, and you get a sequence on the right. An administration drops an updated file into the folder. The next request sees the checksum that has been changed. The template reloads. No rebuild, no redeploy, and no restart. Customization stopped being an engineering task and become a configuration task. Next slide. The third thing that changed and the most affected the speed. For first few weeks, the bottleneck was not writing the code. It was proving the code right or wrong. Every check means starting a container by hand and copying the freshly built jar into it and restarting it and seeding the database again and again and firing the postman request one at a time. Nothing was repeatable by anyone else. So I stopped my feature work and built a proper test harness. So now one commands boot a real FinTech instance, run every templates and check real PDF output. So the whole testing, uh, manual testing is converted into the automated testing during this process. Two fixes made this trustworthy instead of just green. A test report that needs no data. So we test the engine and not the seed data. And automatic permission setup. So security rejection is never a mistaken for a reporting bug. Next slide. So phase 4 delivered each mergeable on its own, 132 reports down to 66 valid templates. 5 outputs from one engine, and 0 restarts to change the report. One template per report instead of 2, memory flat under load, and full test suite on one command, starting from no test at all. So the line at the bottom matters most to me. Every number here is reproducible from the merged branch, and none of it depends on me still being around. So next slide. I cannot show a live demo today. So here is the shortest honest version of one. 3 commands. Command 1, the migration tool runs on 132 Pentao reports and archives it into the 66 templates in about 33 seconds. So month of manual work is now a build-up step. The command 2, a normal request returns streamed PDF, and that same request works on either of the database because the dialect is decided at the runtime. Command 3 is one of the favorite commands. That is, copy a file into the folder that it is, and every user sees the updated report on their next request. So next slide. So next step is divided into 2 halves. The band at the top is flagship. So here we can improve the whole reporting plugin into the next steps, which comprises of like today, testing a report still needs a human to work out what data it depends on and create the data by hand. So the next framework should read a template, work out on which offices depends on, creates the data by hand, and loans depends on clients and loans the query needs, use FinRec's own API to create the state before running the test. That turns report validation into self-provisioning regression suite. So that is what I want to build next, along with the clearing quarantined reports and staying on as reviewer. So the next contributor has someone who knows this code. For the community, bring the new formats into the user interface and asynchronous and batch execution and exploring charting, because BIRT engine is now completely untapped. So next slide. So this whole journey and the project was shaped by review, not written one. I want to thank Francisco that reviewed each one of my single pull request, the renderer design, the way the pipeline is broken apart, his review comments, and not my first drafts. He also set my rules on using AI and taught me how to use AI and how to validate everything using AI. And I want to thank Victor for the main 2 decisions, that is first container-based testing approach and keeping the templates outside the source code. He also told me to split the template delivery out of the engine change, which is the only reason 15,000 line difference was reviewable at that time. Next slide. So finally, everything is public, and the final report is the first link. The QR code on the right is my report that I've documented the whole journey, and which can help every contributor that are looking to contribute in Mifos X reporting module. And it contains of full write-up, the diagrams, every pull request. So far, I have merged 20 pull requests into the reporting module, and I will continue contributing and doing it. So to help releasing the first version of Mifos X, and the 66 templates ship as a downloadable release, so any institution can adopt them without touching the code. So thank you to Francisco, to Victor, and to the whole Mifos community for the reviews and for this wonderful journey. And I also want to thank Ed and David for giving me this opportunity for the summer internship. It's been a great journey. Thank you.
Thank you, Raghav. That's absolutely great. And I think, this is such a really nice module that will really be in the next release of Mifos X out there. I know it's been asked for in demand a lot. There's been a lot of chatter with the Pentaho 1 breaking as to what was going to happen next, and I think, it epitomizes you've not just taken it and repeated it and taken the same mistakes through into the new one. You've actually taken it apart, looked underneath the cover, worked with your mentors, found a solution that's better, not just a replacement. And I think that's what really shines through as we go through this. So this is going to be an absolutely great addition to the Mifos X product as we move on. Next, I'm going to hand across to Albin. Albin's been working on the whole workflow mechanism and how do we actually, cope with workflows? How do we plug it in? How do we change workflow mechanisms, etc.? So, Albin, over to you to explain far better than I can do in a quick 30-second handover.
So my name is Albin. I'm working on Pluggable workflow engine, and yeah, first of all, earlier everything is hardware in FinRack. So if there are some business logics and everything, we are written on everything in FinRack. So why we need workflow engine is that if there it doesn't need a Java file to create if-else conditions. It's all business logic and everything managed by BPM. So uh, earlier before the midterm presentation, what I actually created is that a monolithic I converted monolithic structure to Maven multi-module. So in that, what I did was I created a SPA folder, and SPA folder contains all the interfaces and bundle every interfaces to a single file. And I moved 65 files to into a core and workflow service SPA. It contains all engine neutral codes. So, and I created a separate folders for each engine, and every engine has its own delegates and implementations are everything is happening in that folder. So this was my midterm up to my work in midterm. So there are many issues in this design. First of all, that actually we moved from Maven to Gradle. So that is one issue. And other issue is that every interfaces in one file creates some problem is that some engines doesn't need some interface, some methods. So everything in one interfaces makes it difficult to debug and write that files. So after the midterm evaluation and everything, Alex created a new skeleton and new structure. And what he did is created a main two domains like modules. In the modules, two folders, infrastructure and FinRack. And that infrastructure and FinRack is completely isolated and each other. The infrastructure doesn't know about the FinRack, like banking rules and banking things. And FinRack doesn't know which engine and everything. So infrastructure maintain all the engine related things, and whereas FinRack maintain every bank related things. This was we created. And this was created by Alex. So from my SPA interfaces, everything in one file now is created to each methods in each file. So if a deploy have a deploy method and delete have delete method, everything is a single file, and each file having only single method. So it is actually to created and deleting a single file and maintaining a file. So every methods have two main things: a response and request. So every response and request we created in use case classes and model classes. So that if there are if the future if there are new any methods come up, we can simply added that method to our interfaces. And the same engine we have two directions like use case global whereas support global. So use case global and support global, like use case is what we actually that application that calls the engine, and whereas support is used for that engine is calling the application. So from earlier we have only two. From midterm I only planned about two engines, global and Camunda, and later after the Alex restructuring the everything, he given a 7 engines, and all the engines having same type of methods and everything. Only the interface implementation only changes, but rest of the things are similar to each other. So it is easy for any type of engine can easily accommodate and easily pluggable with the new structure. So current structure how the request reaches the engine from the API endpoint, it directly goes to common Mifos context request filter, and from that it goes to the Mifos platform use case interface. So the interface doesn't know about the engine. From the interfaces based on the based on the file requirement and which engine is enabled. Based on that conditions, it goes to the global stack use case. If commuter, then it goes to commuter flow stack use cases. And same for the engine calls back. from engine calls batch also from BPN reaches to the probable use case delegate, and from its resolved and FinRed client, etc. So the other thing was in the midterm evaluation, one problem is that 16 delegate classes, if there are all each 16 delegate classes, we need to create a 16 delegate files we have 16 delegate classes. So if there are hundreds, that is an issue. So after the new structure, Alex giving a clear pathway, like if there is one creating a day one delegate classes for everything. So it is simple in structure and easy to maintain. So this new structure helps to developers to add more use cases like without changing anything. And every we decide each engine, everything is based on the property files. So property when each like every class there is a conditional boolean property we use, and each here which probable engine is enabled. Like if it command or flowable or anything, it goes to check the property. First it check the property. If it enabled, then it creates only the particular bean is created. So there is no other controls or other use case classes created. So it always created the particular engines. And uh, yeah, the project was restructured midway. So that is the main issue for me. And from the grading, it was actually a good structure and good planning. Earlier, my plan was created many issues, but new structure given more adaptable and more convenient to users. Like it don't need to manage 1,000 lines of code, only small line of code, and each is separated files. So and everything from keep private. So one file the cannot access from outside the file. So that is also one of the main advantages of new structure. And this was the earlier project, and this is right our new project. And in new project infrastructure, the core contains all the use case, all the interfaces, use case models, exception, all inside the core. And use cases contain the we call the engine and support from the engine as we mentioned earlier. And transport contains the process controls. So this folder structure is common for all the new folder structure. If we created a new folder or new module in our new structure, we need to keep the same modules folder structure. So from what we actually implemented is that from the flowable, I can only work on flowable. The flowable only 7 out of 9 use cases we created. Out of that, I completed 7, and I changed some files like some issues. So I changed some structure in here, and also completed 9 reports with the 6 messages. And 3 changes what I created is that earlier, from the new structure, it was input string. So Jackson cannot deserialize that an issue. So I changed it from input string to string. And second thing is that when returning a task, it's always a list of tasks. So new implementation, it's only return single. So I need to change that. So I changed it from instead of returning single task, I created a list of tasks to return, and same for the history response. So these are some real test cases, and this is some postman input files like given. First one is deploy method. So here the input is name and process definition. And the process definition, I take the BPN file, loan origination BPN file, and then I got a deploy ID. So after that deploy ID, then we need to start the engine. So we need to give the variables like loan of who is a loaner, approver, or like extra details we need to pass. And there we get a process ID. So if we given if these are the sample data, this is not the real actual data. This is I just for the demo purpose only. And when we given a user ID, this is user ID always not like a name. It's a name. It's a string. If we given a user ID, it gives all the details like task ID, name, process ID, process definition, everything we will get. So from the process definition, if we take the process ID, we can check the complete like if you pass the task ID as a process ID, we can get that task as completed. And again, we check the pending. We can see that it description changed to review the loan application. Earlier, it was loan officer submit the loan application. So that other use cases, and other use cases is history. So when the history, we need a process ID, and passing process ID, we can see the entire list of returning as a list. Earlier it was returning as a single. Now it return as a list, and from that delete history and delete also. From delete, we are completely deleting the entire deployment from the engine. So for that, we need a deployment ID when we create it. So given that passing the deployment ID, we can delete the entire engine. So this was the use cases currently created in Pluggable. So same method, we can also create use cases for other engines, and all the engines having same structure. So only the implementation changes. And currently the working two things you need to complete it. Two things are single signal and response are the some pending task for me. And one other pending task me is that changing to Postgres. So earlier it was not in, it was in MySQL, and currently it works on H2 database. So it need to convert or migrate from there to Postgres. And yeah, and for me, Signal, yeah, then these are the concept Postgres. Then for community, there is small issues with some dependencies and some files. Like there are a lot of files and SDKs we are there. So there are issues with some files like filter upstream. There is no library. Some library cannot run. Also, some engines are not currently fixed properly. Need some more works on that. And yeah, that's about my project. And the project report is you can see entire project report from my folder. And yeah, it's actually a good experience for me this summer of code, because I was really working on, first of all, midterm I was working on a Maven project, and later the entire shift from Maven to Gradle, and it was the structure of new structure was really better than what I thought. Like the Alex given a good idea how to given a structure and everything, that is better, given a better idea for me. And yeah, thank you, David and Edie, for this opportunity for the internship. Yeah, thank you.
Thank you, Albin. Great work. It's good to see that the workflow is an important part of what we do at Mifos X to bring the product all together. And it's good to see some of the options you started exploring, and also the direction that you need to take it over the next few weeks, looking at Postgres, etc. So it's great to see that. Thank you for presenting that. Thank you to all our presenters today. A quick reminder, we do have some time. So if you have some questions for any of the presenters today, please do put them in the Q&A system, and we'll try and come to them. But Ed, over to yourself. What do you think about what you've seen today?
Thanks, David. No, thank you to all our interns today. It's really impressive to see the depth and breadth of contributions across the Mifos X platform, as well as some contributions to the Fineract backend as well. I'm really impressed by the level of technical expertise and the depth of the contributions that our interns have made, and eager to get all of this incorporated into the forthcoming releases. So we'll be releasing the plans for the next upcoming Mifos X releases soon, and we're eager to incorporate as many of the contributions from our interns into those releases. And I want to thank all our presenters today, as well as thank our mentors who have been guiding our interns over the past several months, and really happy to see that there's strong interest in continuing beyond the summer. So it's going to be great to continue to cultivate and grow the contributions you've made this summer, and hopefully get the rest of the community to begin contributing as well. But I'm looking forward to the next 3 days of showcases, which will be Wednesday, Thursday, and Friday for this week. But like David said, the Q&A is open if any of our attendees have questions for our interns.
Thank you, Ed. Yeah, I can't see any questions at the moment, but I'll keep an eye on it for a few more minutes. So please get your questions in if you do. And as you say, Ed, we've got a great set of sessions coming up over the next few days as well. So the next session we have on Wednesday, and we'll send out the link to General again, so everybody's got the link to register for it. We'll focus on Mifos, Gazelle, and Payment Hub, and some of the really exciting stuff that will be in the next releases of both of them. Payment Hub is aiming for a very significant milestone with 2.0 coming out this year. So some really great work to demonstrate there alongside Gazelle, which continues to work with other DPGs. Then on Thursday, we will be looking a bit more at Mifos X again, and the mobile applications specifically, and what that's doing. And then on Friday, we'll wrap up with a bit more of a focus on AI and how AI is enhancing all of our products that we have out there. So that'll be a good session to end the week on. I can't see any questions having come in on the Q&A. Yeah, just to remind you all, please do join for all the other sessions that we have coming up this week. And a huge thank you to all the presenters, the mentors, and all the work that's gone in over the summer. It's great to see it, but really hard to pack into 20 minutes. So really do appreciate all the effort each of them has done to get to this presentation.